So a nice formula or equation for the solution to y of x is preferred over a list of approximate values. So one method for generating, again, this is just one method, for generating a numerical solution to a differential equation is called Eulers Method. Eulers Method is based on approximating the graph of a solution y of x with a sequence of tangent line approximations, computed sequentially in steps. So you know, sometimes you're driving down the road and your GPS, sometimes it recalculates. It has to do this recalculation. You kind of look at this idea. So let's take a look here. So here's a point x sub 0, y sub 0. Here's x sub 4, y sub 4. What we're looking at, okay, I'm going to estimate what the difference is between these 2 points from here to here. It's not a very good approximation. So I'm going to recalculate it, and I'm going to bring it closer, reapproximate it, closer and closer to what the actual value is. So what we're doing is we're approximating a y value at a particular x value. We're starting at one point, and we're going to end up at another point. And again, we're using a tangent line to get this approximation. So again, what we have here is we're looking at x minus x sub 1. This is your change in x. They will tell you what the change in x is, or you'll be able to tell exactly what it is because they say you're going to do 3 increments or whatever. This, remember, is a dx. So x sub n, y sub n. This is your old point that's given. This is your new point. So what Eulers method is going to do is this. We know we've got our tangent line. This is our tangent line approximation. So looking at my old point versus the new points given. So again, I can rewrite this equation of my tangent line as y sub n plus 1, which was my new point, minus y sub n, equals, again, I know my slope is just dy dx, times the difference in the x values is my dx, or the change in x. I'm going to use my delta x so we don't get this confused. So now if I solve for this new y value, y sub n plus 1 is equal to my dy dx times my change in x minus or plus y sub n. So what this is saying, in essence, is I can calculate the new y is equal to my old y, which is this one right here, just moving it to the front, plus your y prime times your change in x. So when you're doing Eulers method to come up with an approximation, easiest way to do it is to make a chart. They have to give you a starting point. So here's your x and your y. So you fill out your x and y. And again, you're going to come up with your new y is equal to your old y plus your dy dx times your change in x. That's basically the chart we're going to build to help us come up. Again, what we're doing is they're going to give us a point, x comma y. So let's say, for example, they may say that when x is 1, y is 3. Use your Eulers method to calculate approximation of f of 2. And they may say use 3 steps or 4 steps. Well, if they use 4 steps, you're starting at an x value of 1 and you're going to an x value of 2. Your change in x would be a 0.25. All right, so that's what we're going we'll be taking a look at that when we get into the examples. So one thing we also, this kind of goes into, we talked about this earlier when we are doing our local linear approximations. To determine whether an approximation is over or under, we find the second derivative. Remember, if your second derivative is positive, then f is concave up at that point. So the approximation is an underestimation. Again, concave up, there's your tangent line, so it's going to be an underestimation. If your second derivative is less than 0, that means that f is concave down at that point. So your approximation is going to be an overestimate. Again, here's your concave up, there's your tangent line. So here's an example. Notice they're going to give you the derivative or the differential equations. dy dx is equal to x minus y. They're giving us this initial starting point, y of 0 is equal to 1. Our change in x is 0.5. They want us to approximate y of 1.5 and determine whether this approximation is an over or under approximation. So again, what we do is we're going to build the chart. Here's your x. Here's your y. So the point they're giving you to start at is when x is equal to 0, the y value is 1. So first of all, what you want to do, your dy dx is equal to x minus y. So what we're going to do is we're going to solve for the change in y by multiplying by dx. So dy is equal to x minus y times dx. They're telling you what the change in x is. The change in x is 0.5. So that is your dx. So dx is equal to 0.5. So then my change in y is going to be x minus y times 0.5. So now to calculate my new y, it's going to be my old y plus the change in y, which is dy. And again, my old y plus dy is going to be x minus y times 0.5. That's how we come up with the new y value. So now what I want to do is I'm going to calculate my old y is this y value right here, which is 1, plus I'm going to take my x and y value and I'm going to subtract it. So I have 0 minus 1 times 0.5. So I have 1 plus negative 0.5. So when I have negative 1 times 0.5 is negative 0.5 plus 1, then my new y is going to be what? 0.5. So then I know my change in x is 0.5. So my next x value is going to be 0.5. My new y value will be 0.5. So any questions on what I've done so far? So now I'm going to do this again. Again, I want to calculate what y of 1.5 is going to be. So x is 0, this is 0.5, the next one's going to be 1, and then this is going to be 1.5. So I have repeating this process until I get down to my x value of 1.5. Because again, they're telling me my change in x is 0.5. So the x values are going up by 0.5. The issue is I do not know what that dy is. So I have to calculate the dy and keep on adding it to the old y. Does that make sense to everybody in terms of what I'm doing? All right, so now what I have to do, I always just calculate my, my dy first. So again, it's going to be 0.5 minus 0.5 times my change in x, which is 0.5. So 0.5 minus 0.5 is 0. 0 times 0.5 is going to give me 0. So my old y is 0.5 plus 0, which is going to give me another 0.5. So now I need to calculate my next change in y. So it's going to be x minus y, so 1 minus 0.5, times my change in x, which is 0.5. This is my dy. So I have 0.5 times 0.5, and 0.5 times 0.5 is going to give me a 0.25. And now I need to add my old y to it, which is a plus 0.5. So it gives me my 0.75. So now what I've just found is that my approximation f of 1.5 is going to be approximately equal to 0.75. So any questions on where I got 0.75 from? When we get into Chapter 9, the second part, this is just a linear using a first-order differential equation. We'll get into higher-order approximations when we get into Chapter 9 into the second part. But this is just using a degree of 1, all right, approximation. Now the next question is they want me to determine whether the approximation is under or over. So this is where we're going to use that second derivative test again. So we have my dy dx is equal to x minus y. So what we need to do is we need to calculate the second derivative. So the derivative of x is what? 1. Minus the derivative of y, use your implicit differentiation, is dy dx. And again, what we need to do is we need to evaluate what this approximation is. So I want to evaluate this derivative at 1.5, comma 0.75. So I have 1 minus. Now, dy dx, remember when you do implicit differentiation, we have to take the value of the first derivative at your 1.5 and 0.75 and plug it into your first derivative. So again, my first derivative is going to be 1.5 minus 0.75. So that's going to give me 0.75. So then the value of dy dx at 1.5 and 0.75 is 0.75, which is 0.25. So again, at the second derivative, 1.5 and 0.75 is greater than 0. So what does that tell you about your function at 1.5 and 0.75? Is it concave up or concave down? Concave up. So I know it's concave up. Therefore, is this going to be an over approximation or under approximation? Under. So it's an under approximation. So any questions on using Eulers' method to get an approximation and then discover whether or not it's going to be an over or under approximation? All right, so here's another example. Again, I'm given this differential equation, and you can tell by the answer choices, these could be calculator or no calculator questions. So this is an example of one where it's no calculator. The second one, obviously, looking at the answer choices, you'll be allowed to use your calculator for. So again, they're giving you the derivative, dy dx is equal to negative x over y, and y is equal to 4 when x is equal to negative 3. What is the approximate value of y when x is equal to negative 3.6, using Eulers' method with a change in x of negative 0.2? So again, I'm going to build my chart. So here's my x, here's my y. So again, they're starting at the point negative 3, 4. So now dy is going to be equal to negative x over y times dx. So that's going to be my change in y. What are they telling me about dx? Dx, my change in x is what? Negative 0.2. So then dy is going to be equal to negative x over y times negative 0.2. And you could write this as just x over y times 0.2 if you want, since I know a negative times a negative is a positive. All right, so then dy, so then my new y will be equal to old y plus my dy, which is going to be x over y times 0.2. Again, you can leave it as negative x over y times negative 0.2, where we know a negative times a negative is a positive. So now I'm trying to estimate negative 3.6 with a change in x of negative 0.2. So I like to go ahead and fill out my x values first so I know exactly how many I'll have to do. So my next x value is going to be negative 3.2. My next x value will be negative 3.4, because again my change in x is negative 0.2, so I'm just adding negative 0.2 to these x values, and then negative 3.6. So now I'm going to take my x value and divide it by my y value, which is negative 3 over 4, times my 0.2. And again, that's going to give me negative 0.75 times 0.2, negative 0.15. And I have to add that to my old y. So negative 0.15 plus 4 is going to give me 3.85. So now I need to calculate again. I need to take my x value, which is negative 3.2, divide it by the y value of 3.85, and then multiply by 0.2. So negative 3.2 divided by 3.85 times 0.2. End up with about negative 1.66. Negative 0.166. And I have to add that to my old y of 3.85. So that gives me 3.684. So now to repeat the process again, I'm going to take my x value, which is negative 3.4, divided by my y value of 3.684, and I'm going to multiply by 0.2. So I end up with my dy to be negative 0.185. Add that to my old y of 3.684. And I end up with negative 3.6 is approximately equal to 3.499. So your answer choice is going to be C. Okay? But that's your Eulers method. So any questions on how you use Eulers method? And then obviously if they took it the second part to over or underestimation, you have to find the second derivative and check to see if it's concave up or concave down at that particular point. Okay? But that's it for Eulers method. Any questions on that? Like I said, I told you it's a pretty short lesson here today. All right? And like I said, gotta do some catching up.